The official system requirement for LTX 2.3 is a minimum of 32 gigabytes. Well, my laptop has 4. Their own definition of making it low VRAM is 32 gigabytes. Community guides seem to get it down to 12 gigabytes, which is about a 3060. The lowest anyone publicly has shown is probably me, which is 4 gigabytes. But for this video, I took every VRAM trick the guides swear by, and I benchmarked all of them on this machine, same prompt, same seed, full renders, every single run, hours of them. Okay, here's what we want to do. First, we're going to benchmark all these different tricks, and then we take everything that actually worked, try to combine it to get the fastest generation on 4 gigabytes of VRAM. Spoiler, the 2 most recommended tricks on the internet made this laptop slower. 1 couldn't even start, and the 2 that won't aren't in any guide. Baseline first, so the numbers mean something. LTX 2.3 dev model, GTUF version Q4KM, my workflow, stock settings, dev instead of distilled on purpose. More steps, bigger, cleaner differences between tricks. And here's what running a 22 billion model on 4 gigs actually looks like. Nothing fits. The model lives in system RAM and streams through the card. VRAM sits at 100% from second 1. That gauge tells you nothing here. What matters is seconds per step and the clock. The baseline took 1 hour and 6 minutes flat. Yeah, an hour for only 5 seconds of video. That's the number to beat. And now you know why the guides say 32 gigabyte. One of the most recommended fixes on the internet are launch flags. Every low VRAM guide opens with these. Result, 1 hour and 59 minutes. The flags nearly doubled my generation time, plus 82%. That is not okay. And when you think about it, it makes sense. Those flags manage VRAM for cards that have VRAM to manage. On 4 gigs, everything is already offloaded. The flags just added overhead to a system that was already doing the work. Next, the hype trick, Sage. The claim says 30% faster attention. First problem is installing it. It is nearly impossible to install on a normal ComfUI desktop environment, and it is still nearly impossible on the newest updates of ComfUI. So I had to downgrade a few things, including CUDA, to get it to run. Now, I wanted to run the KeyJ node version of SageAttention. It has memory efficient nodes that are supposed to make it faster. However, I did not get that to work. I did get to work the attention override. And on my 3050 Ti, that actually gave me a 38% decrease. Now, I do want to say here, SageAttention actually does make things faster if you have the right computer. On my 3060, I usually get a 30% increase in attention speed. But for a card this bad and this low, it just adds more overhead. It will not make it fast. Torch.compile, the trick that supposedly halved VAN generations on a 4090. On this laptop, it has a problem nobody mentioned. The first compile pass needs extra VRAM on top of everything because it is compiling. There is no extra, therefore it OMs before producing a single frame. Before the comments arrive, these tricks are not fake. Sage works. It works great on better card. It works great on my 3060 over there. On a 40 series, it's exactly as good as the benchmarks say. Same with torch.compile. If you have the headroom for the compile pass. The problem is that every guy, every benchmark, every install tutorial was made on cards with VRAM to spare and then recommended to everyone. Nobody tested the bottom. That's the gap this channel exists in. If you're on a 3050, a 4 gigabyte card, maybe a 6 gigabyte card, the standard advice doesn't just not help you, it actively costs you time. Okay, quick thing, everything I do here is completely for free, and as I'm not monetized yet, I do not get any compensation for this. So it would really mean a lot to me if you checked out my Buy Me a Coffee and maybe buy me a coffee. What actually worked? 2 things, and the first one, as far as I can tell, is mine. I showed in the last video, you don't generate at 24 frames per second, you generate at 12. half the frames and use Rive frame interpolation to double the frames, making it 24 again. Half the frames is half the sampling work. Total generation plus interpolation, 54 minutes and 48 seconds. 11 minutes off baseline, minus 17%. Interpolation isn't new, but nobody puts it in the low VRAM list, and it just beats every trick that is in them. The second winner is sitting on the official model card, and the guys just skip it. Lightrick ships a distilled version of LTX 2.3 that runs in just 8 steps instead of 20. Same Q for KM quant, so it's a fair fight. 40 minutes, 22 seconds, which is minus 39%. The single biggest win on the board, and its first party. The question this whole video was for: distilled model, 12 FPS, no flags, no Sage, no compile, everything that won, nothing that lost. The fastest LTX 2.3 generation this laptop can do. Let's build it and run it. Verdict: on 4 GB, skip the flags, skip Sage, skip compile, run only the distilled model, run it with 12 FPS and use frame generation, and you will have faster results. If there's a trick I missed, let me know down in the comments. Every trick that's legitimate, I will try in the next episode. Alright, and I will see you guys in the next one.